All right, welcome back, everyone. We're up to lesson 6. This particular lesson actually has no new lesson notes, so we're going to go right ahead and get right into the examples for lesson 6. There will be some lessons in this course that don't have new lesson notes. What that means is that we'll just refer back to our notes from previous lessons. So let's take a look at our first part of our examples. For each of the following sequences, geometric, arithmetic, or neither, and then write a recursive definition. So this is a review of the previous lesson. So let's first go through each of the 4 here to determine what type of sequences they are. So we can see for number 1, we go from 3 to 7 to 11 to 15. That is clearly an arithmetic sequence. Why is it an arithmetic sequence? Because my pattern is to add 4 each time. 3 plus 4 is 7. 7 plus 4 is 11, so on and so forth. Number 2 is a little different. Okay, number 2 we may need to use a calculator for. So I'm going to pull up the calculator on my phone here. You could use the calculator on your phone. You can use the calculator on your computer. If you want to use Desmos, that's fine too. It's whichever you prefer. So to figure out what our pattern is, it looks like our pattern is to divide. The question is 10,000 divided by what is 2,500. So I'm going to just double check on my calculator here. It's not divided by 2. It looks like our pattern is to divide by 4 because 10,000 divided by 4 is 2,500. 2,500 divided by 4 is 625. So my pattern is to divide by 4, which means that this is a geometric sequence. And we're going to say that our common ratio is not 4, it's going to be 1/4, because dividing by 4 is the same as multiplying by 1/4. Okay, so that's number 2. Number 3, we go from 1 to 4 to 16 to 64. That looks like quadrupling to me, multiplying by 4. So this is clearly going to be another geometric sequence because my pattern is to multiply by 4 each time. And number 4, let's see here, 10, 8, 6, 4. That is pretty clearly going to be an arithmetic sequence. Why arithmetic? Because I am minusing 2 each time. 10 minus 2 is 8. 8 minus 2 is 6, so on and so forth. So my pattern is to multiply by 2. Now that I know the patterns and the type of sequence, I can now go ahead and write the recursive definition for each. So remember from yesterday's lesson that the recursive definition has 2 parts. The first part is my starting term, my f of 0. And in this case, my f of 0 is going to be 3 for number 1. So f of 0 is going to be 3. And then we're going to write how we get a new term from previous terms. So the way we do that is to write f of n equals f of n minus 1, and then we're going to write the pattern. The pattern in this case was to add 4 each time. So the second part is going to be f of n equals f of n minus 1 plus 4. And these 2 parts is the entire recursive definition or recursive form for number 1. Okay. Number 2, my starting term, so my f of 0 is going to be 10,000, right? Because that's our starting term. And then we're going to say f of n equals f of n minus 1 And our pattern is to multiply by 1/4, so times 1/4. So that is your answer to number 2. Number 3, my f of 0 in this case is going to be 1. And my pattern is going to be f of n equals f of n minus 1. And my pattern is to multiply by 4, so times 4. And then the last one, my f of 0 is going to be 10. That's my starting term. And then we'll have f of n equals f of n minus 1. And my pattern is minus 2. Subtract 2 each time. So these are my recursive definitions or recursive forms for each of these sequences. Okay, so that's the first part of our examples. Just a review of what we talked about in the previous lesson. I do have a couple more examples, so let's take a look at those. So for this one, we're given a recursive definition. Consider the following sequence with the recursive definition f of 0 equals 2, and f of n equals f of n minus 1 times 2.5. Is this geometric, arithmetic, or neither? Well, the giveaway in this case is that the pattern is to multiply by 2.5. So multiplying by 2.5 means that this is a geometric sequence because we are multiplying by the same number each time. Number 6, write the first 5 terms of the sequence. So my starting term in this case is obviously going to be 2. And then what does this recursive definition says? It says to go to a new term, to get a new term. My new term equals the previous term times 2.5. So to get the second term of a sequence, I'm going to go to my calculator, and I'm going to take the first term, which was 2, and multiply that by 2.5, and I get a second term of 5. So to get my third term, I'm going to take the second term, which was 5, and multiply that by 2.5. And I end up getting 12.5. So we have the first 3. We need to do 2 more. So now I'm going to take 12.5 and multiply that by 2.5. And I get 31.25. And then for the fifth term, I'm going to take 31.25 and multiply that by 2.5 on a calculator. And I end up with 78.125. So what are the first 5 terms of this sequence? It is this right here. How did I get it? I knew from my recursive definition that I had to start at 2, and then to get each new term, I took the previous term and multiplied it by 2.5. I literally used the recursive form to find the other 4 terms, the second, third, fourth, and fifth terms of the sequences. That is it for this lesson.